Our hypothesis was that the increase of macroinvertebrates in an aquatic environment indicates favorable water quality. Our research was to find a correlation between macroinvertebrates and water quality. If our hypothesis was proven, then people could easily understand the quality of water before doing various activities to avoid getting sick. This also helps establish early indicators of water quality so it can be fixed quicker through observing macroinvertebrates and taking test samples.
Are to help people and communities determine the quality of an aquatic environment in an affordable manner. The use of macroinvertebrates is to observe the amount of macroinvertebrates, amount of type of species, pollution tolerance of each species. To do this, we would compare the macroinvertebrate data to the water quality test strip data to observe the correlation between the variables, and the use of macroinvertebrates to see the connection between the macroinvertebrates and the quality of water.
Macroinvertebrates are found inside aquatic ecosystems and are on a scale from tolerant to intolerant to water pollution in their environment. By identifying the amount of species, the tolerance of those species, and the amount of macroinvertebrates, we hope to be able to determine the quality of a body of water. This is based on the concept of bioindication, where different species have different tolerances to levels of pollution. Because these macroinvertebrates live in the body of water for significant portions of their lives and have limited mobility, the macroinvertebrate populations provide reliable, long-term pictures of an aquatic ecosystem's health that a chemical test is unable to do. The community structure of macroinvertebrates changes in response to environmental stressors, making it easy to analyze the diversity, abundance, and types of organisms present in water.
The main indicators of water quality in macroinvertebrates include both diversity and the types of species present. While a healthy pond will have a wide variety of different types of macroinvertebrates, an unhealthy pond will have only a few types of macroinvertebrates, mostly those with high tolerance of pollution and low dissolved oxygen levels.
Organisms that need clean, well-oxygenated water to survive are intolerant. Their presence indicates good water quality. Species that exist in wider ranges of water quality, including some levels of pollution, are moderately tolerant. Organisms that can thrive in polluted waters are tolerant, and their dominance indicates poor water quality. High diversity, it means a balanced community. A healthy aquatic ecosystem typically has a high diversity of macroinvertebrates with a good mix of sensitive and tolerant species. In low diversity, the tolerant species are dominant. As pollution increases, intolerant species die off, leaving a less diverse community dominated by highly tolerant organisms.
For our first trial, we had 7 gnats, which are highly tolerant to pollution, meaning they can survive poor water quality, 3 baby dragonflies, which are sensitive to pollution, and 1 snail, which is highly tolerant to pollution.
We found gnats and baby dragonflies within the water. We found 8 gnats and 6 baby dragonflies. Gnats are highly tolerant to pollution, and larvae of gnats and midges can survive in poor water quality conditions. Baby dragonflies are somewhat sensitive to pollution, and the presence of dragonflies suggests that the water can support some sensitivity to life.
Trial 1 had 3 species indicating poor diversity. 2 out of the 3 were pollution tolerant, indicating poor water quality as they can survive polluted conditions. Trial 2 had only 2 species indicating poor water quality, but 1 out of the 2 were pollution tolerant. Census data indicates moderate water quality, low diversity in species. However, there was a high number of baby dragonflies.
For our first trial, our pH was about 7, and our second trial was 6.8. The pH of 7 tells us that the pond water is neutral, having equal balance of acidity and alkalinity. The pH of 6.8 is similar, but it indicates that the pond is slightly more acidic. It could indicate the pond's alkalinity is low and less able to buffer further changes.
L2, the water hardness was measured to be at 25 ppm. Water source's mineral content is stable, but due to the low level of the water hardness, the water lacks a buffering capacity to prevent sudden and dangerous swings of pH, which can be harmful to the fish and organisms inside the pond.
For both trials, the nitrate was listed at 0 ppm, indicating the pond's nitrogen cycle is working correctly, processing toxic ammonia into nitrite.
So we did additional testing of ammonia and nitrate. The ammonia levels of 0.25 parts per million show that the beneficial bacteria in the pond were not able to process all the waste. This may hurt fish gills and immune system over time. While the nitrate levels of 0 parts per million indicate that the pond has enough plants to consume all the available nitrate.
There was a lack of diversity in species testing, which shows that there's mostly healthy water, but there's a low hardness, which means that it's very susceptible to rapid changes in the pH. One is in the middle of the spectrum from a healthy to an unhealthy pond. The macroinvertebrates show a polluted, unhealthy pond environment, while the water test shows a slightly unhealthy pond due to the possibility of rapid changes in the pH and the environment.
It was dirty, which caused issues while observing the range in which the water was for each water testing parameter. The pH had also had some slight changes, but this could be due to outside factors such as the rain that could have happened the day before. Along with this, macroinvertebrates were hard to find and categorize due to them being so small and being able to move so fast.
Overall, the water quality test showed good water quality with the possibility for there to be slight fluctuations. The fluctuations were seen in the microinvertebrates as they showed a medium health of the water in both tests.
For both water samples was in the middle of the road, as they were not purely unhealthy, but were also not fully healthy either.
We can determine the health status of aquatic environments and use that to help others.
Communities can use macroinvertebrates as an easy tool to check the health of a local pond or stream, using the tools that were identified earlier. Sharing these findings with the community can encourage environmental awareness and support healthy ecosystems.